Recording is on.
I've got a little puppy that's walking around here at my footsteps, a three-legged puppy as it is actually going to be losing another body part tomorrow. Unfortunately, you can probably guess which body part that is. Um, anyway, Sandy has not made a double appointment, which is nice. Um, so thank goodness for small miracles. So yes, here we are. Thursday. That's what Thursday. Wednesday, October 4th. Obviously, that shook me a little bit, but this. Oh, and look what he has in his mouth. He grabbed the Windows 7 installation XP disk. You bad dog. Here, I have to pick him up and show him to you. So this is him. This is Chubby or Chubs. He's about 7 months old, something like that. Um, like I said, he's got one leg here, but only one in the back. So
just lost sound.
I think you muted.
I was afraid it was me.
he's a smart dog. He pressed the M button. I guess he didn't want to have anything divulged about his personal medical history. So anyway, so that's the little puppy that I adopted. I don't know, a month and a half ago, something like that. Oh. And he's heavy. He's close to 50 pounds now. So anyway, he likes chewing
Sign
on
him up.
things.
Sign
Sorry?
him up for SOAREX. Sign him up
Yeah.
for SOAREX membership.
For SOAREX meetings and field days. So
Yeah.
anyway, all right. So welcome everybody. I guess I do have to do my little statement here, which is please note that all of our meetings are recorded and made available to the public for viewing on our YouTube channel. By participating in this meeting is understood that you've accepted these terms for all of those assembled. So, all right. I know we have two things on our agenda, which Peter gracelessly provided, which is Drew is going to give us a presentation on some 3D printing topics. I believe a bit of a primer of that. And then Peter's got something to tell us about LT Spice, I guess 101 lecture number 2. And then I've got to briefly talk about our trip to FDIM next year. Just get a general sense of who's coming and tell you what the current options are as far as accommodation and see what the logistics are, see when people are interested in going down there, what day of the week, basically. So we have some options there. After that, we'll go around the screen, see what everybody's working on, what's new, and that'll probably be that. So does anyone have anything else that they wanted to put on the agenda for this evening? Anyone? Going once, going twice? Nope. Okay. All right. Well, we can get started without any further ado. Drew, would you like to start us off with some 3D printing knowledge?
I will. Give me a second here. I'm going to clear my screens and see if I can do this. It's been a while. Okay, so that's the one I want.
Teach us how to print these.
Let me see.
Those are loaded dice. Drew's an odd guy.
Oh yeah. Those are Toronto dice.
Toronto dice, yeah.
Yeah, coming up snake eyes all the time.
Boxcars, lucky boxcars.
So let me choose the screen I'm going to show. Window.
See, that's the difference between Dave and I. See, he has all these practical things, hangers for his drones up on his wall. What do I print? I print dice.
Well, yeah, I don't blame you. I didn't bother bringing up all the stuff I printed because, now, can you all see that?
Yep, looks good.
Very good. Okay, so bearing in mind, I wasn't given a lot of guidance as to what intro to 3D printing people wanted. So I made this up based on kind of what I did. And I will tell you that I've been doing this for about 7 years. And I started out on an older machine that still works today. and it looks an awful lot like a Prusa. And as we go along, we'll discover the various names and the like. Anyways, none of that's overly important. People get very taken aback by the concept of 3D printing. And 3D printing is what I've described here. Now, those of you who are long in the tooth, such as I am, will remember the old HP 74, 75A plotters, which were wonderful little XY plotters that you could buy with felt tip pens, and they were good enough that they could very accurately simulate a signature. And you take that and a glue gun and the ability to screw it up and down, and essentially you've got a 3D printer that everybody's talking about. I like to think that people started out using whippersnipper line in their systems. I've thought about it, and I must admit I think it would work too. But they're simple machines, and the technology is very, very well understood. And it all runs on an Arduino, and there's not a lot of super hardware on it, some stepper motors and threaded rod and some robust structure. And so, when it comes to buying one, you don't have to spend $1 million to get one by any means. But as a starter, there's my next one. A little history. They've been around a lot longer than I certainly thought. And the original patents, even 30 some years old. What I'm going to be describing is the fused deposition type of system. There's lots of different systems out there. This is the more traditional, the one everybody sees. 2005, things started to get rolling. And then 2009, the first patent expired, and that was it. Off they went. I bought my first machine, as I said, about 7 years ago. And by then, 3D printers were part of the common parlance, even in the newspapers, so they were coming around. 2010 was a neat one, and I have one of these printers. It is a Prusa Mendel, and it was touted as the printer that would print itself. And what you did is you found someone who had one, and you took the plans, and you printed out all the supports, you added in some threaded rod, and you had the structure for your printer. And it's incredibly robust. I was surprised at how tough these things are. So I actually have one from the original days and didn't pay very much, $25 for it or something. And I've actually kept it. I was going to tear it apart and use it for something else, and I thought, this is pretty neat. So I still have it. And if you look up Prusa Mendel, that was the first most commonly available printer that was out there. And that's what started off this whole revolution. So since then, we've had a lot of them come and go. And this list of names is very, this is the ones you run into all the time. You get ads on Facebook. Everybody now, because, we're doing this over the internet, we'll get ads on Facebook for Creality and Ultimaker. MakerBot, maybe not so much. They tend to be more expensive these days. Prusa is probably one of the best known higher end machines. Very, very high quality reproduction. Creality is they make the Enders. The Ender CR10, the Ender 3, the Ender 5, all that sort of thing. More entry level, very, very capable machines. Don't let the low price fool you. You can, of course, spend as much as you could conceive and more. Ask the Defense Department. And this is only one of many different kinds of 3D printers that are out there. Resin 3D printing is very, very popular these days. And you find it mostly in the basements of people who make little tiny people for gaming. Apparently, it's an entire industry that people make these little gaming figurines and paint them all up and give them, Dungeons and Dragons. I'm not quite sure what it is. Anyways, it is very popular. And Resin 3D is it's an entirely different animal, but much higher resolution. You don't get the choice of filaments, however. So for prototyping and that sort of thing, not what you want to do. If you're into model making, Resin 3D, which is an entirely different topic, is what you're looking for. So the entire process from one end to the other, you have to have something to print. And there's lots of different ways to do this. I'll divert with a small story. When I first got this thing, I really didn't know what I was going to do with it, but my son had come home with a project. And ultimately, the project became create a small art museum. So, after a few YouTube videos and downloading some software, I found myself printing little tiny statues of various revolutionary heroes, Che Guevara, that sort of thing. So I found them on Thingiverse. They were easy to find. Making things, Tinkercad wasn't out then. Fusion 360 was not available. Fusion 360 is an AutoCAD style drafting package, as you can imagine, non-trivial. One of the things that I did early on after I printed up these little pieces for my son's project was to scan myself using the sensor off of a Wii. And it's doable. It's actually not bad resolution. He doesn't want me showing anybody it because it actually looks like him. Given the very poor resolution available on that little Wii sensor, I was astonished at how easy it was to simply put him on a stool, walk around him waving this thing up over his head and the like, and then convert that image into something I could print. And I did that all in about a day. You can do an awful lot of things, even if you can't find it on Thingiverse. And if you can't find it on Thingiverse, just put in the name of what it is you want to build and end it with STL. It's out there. There are people making, well, I had to get a part for a humidifier. I had ultrasonic humidifier. The top was broken off. I bought it over at Value Village. And so I went on to Thingiverse and there it was, the exact part. It's kind of obscure, so to give you an idea of the scope of what's already available. If you're inclined to make things, Tinkercad's quite easy. Standard geometric forms. There are lots of very good YouTube videos on what to do and how to do Tinkercad. You can make up a lot of things with it. Fusion 360, clearly more sophisticated, more capable, bit of a learning curve. All of the printers need, well, the software that converts something the printers can chew on, it all comes in as a stereolithograph file, STL file. Most of the software that you start out with will be Pronterface or Cura, and I'll be referring to Cura quite often. Cura will take an STL file and create something that the printer can eat. And what the printer eats is straight ASCII code. It's quite readable. You can edit it. You can do what you want with it. It's G code is what they call it, and it has been around since automated machining has been around, possibly earlier, but certainly as far as that goes. I dealt with it back in the mid-'80s with a very large machining system that was being used to create injection molder parts. It was the mold for the parts. And sending that code to the printer, to the machining device, was done in G code. And the G code, the ASCII file, contains everything the machine needs to know. So once you've got it created, and I do this, you take the file, stick it into the printer, and turn it on and print it. You don't need a computer to run the machine. So it's different from the current brand of computerized machining devices that are out there. This thing is self-contained. Once it reads the file, off it goes. So I started out with this model as an example. Those of you who are, again, long in the tooth may remember this thing flying past your screens in the mid-'60s with Richard Basehart. And this is the flying sub from Voyage to the Bottom of the Sea. And I always thought it was kind of cool. I was going to put it in my aquarium. So I knew what I was looking for. I went on Thingiverse, and there it was. No surprise. This is what the model would look like, printed out. Well, in theory, it's not really how they come out, and you'll notice that there's a certain differential between reality and wishes when it comes to 3D printed objects. Mostly there's little lines all over them. Anyways, from this point, I got the STL file from Thingiverse, and I brought it into my software, which is called a slicer, and this is from Cura. Ultimaker makes it, and it's available for all machines. There are other ways to do this. This is the way I've chosen to go these days. I started out with not as sophisticated a software package, and it was a little clunkier, but you've got much more control over every aspect of it. That's a software package called Pronterface, and I'm not sure why it's called that. And then once you had Pronterface, you also had Slicer, and Slicer would make the G code for you. This is Cura. It's probably the most common, and it's very, very user-friendly. And the first thing you'll notice is that there's a box underneath this figure, and that is the size of my printer. So in Cura, it has stored, because it knows it's an Ender 3, dimensions of my printer, what it can print. And it's telling me by virtue of the shading on this that the model won't fit. Okay. If you look down the left-hand side, you'll see some very lightly shaded boxes, which allows you to scale it. It allows you to copy it. You can do a lot of things with that STL file just in this software. Do what you want with it, really. And so that's what I did. And I scaled it. And then I told it I wanted to print it with certain parameters that we'll talk about in a minute, and create the G code for me. And it did that. What you see in front of you is what it's going to print. And you can take a look at it, make sure it's sitting on the ground and it's sitting on the bed. And you can also look at the file if you want to. You'll see a little section up there that says Edit G Code, the upper right-hand corner. So this is what it's going to print. And you can advance through this print one layer at a time, all the way up, if you're worried, to see what, in fact, you're going to get. I have enough faith in the system now that I don't bother with that. But if you take a look at the lower right-hand side there, you can advance one layer at a time. So it's very handy to see how the printer is going to behave before you let it loose. If for no other reason than it's aggravating to come halfway down, halfway through the print and find out that there was a big mistake. Usually the software will tell you ahead of time. That's one of the benefits of the newer software, is it looks after you. So this is, this is the actual code generated for that model. Well, it is not all of it, I can assure you. The actual code is many, 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 many pages. However, this gives you an idea what it is. And what you're seeing there, the top end there, is setting the initial conditions. And what I have told it is that I want a layer height of 0.1 millimeters. And it has determined the size of the model in millimeters and the size of the box it can fit in. And M140 S80 is a command telling it to turn on the bed heater and take it to 80 degrees Celsius. Then you'll see M190, keep it at that. M104, set the nozzle temperature at 240. And M109, keep it at that. As it goes down a little farther, you'll see it goes through a couple of resets, then it homes the axes. And this little G29 thing is a very big deal. We will get into that discussion because it's principle and whether or not your print's going to work. And then the first thing it does is it prints a test line. Excuse me, still getting over COVID here. Prints a test line down the side, gets the extrusion working, and then it starts off. And goes on and on and on until it's done, and then it shuts itself down. So this is all quite automatic. The inclination is to walk away from it, and, well, I don't necessarily think that's a great idea. What you want to do instead is keep a close eye on it for the first while until you develop some trust with it. And I have a duplicate slide. So now we get into some of the more, well, again, the beginnings of what will be your journey into this, because this is a long-term process to get good at this. 3 primary types of fibers. These are the things that you can print with. PLA is most common, very, very common. Everybody uses PLA to start with. It's cornstarch-based plastic. It's kind of interesting. When you're printing with it, one of the benefits is that it does not smell like burning ABS pipe, which is what all 3D printers used to smell like. In this case, it's kind of sugary. It smells a little bit like you burn sugar on the stove, but very, very light. So quite nice. Things printed with PLA tend to be a bit brittle. The whole system operates at a lower temperature. So it's a good starter to go with. One thing you have to know about PLA is it draws water from the atmosphere like a fiend. And so once you're done printing, you have to take this filament off the machine and put it back in a plastic bag with some dryer. They give you little dryer packets, silica gel. And you have to keep it as dry as possible. And where that happens to be a problem is, if it does get wet, what will happen is that it'll actually kind of pop and break the filament or gouge the filament, and you'll start having a lot of trouble with it. And then ultimately it becomes brittle and breaks. So PLA requires a little handling, but it's the one everybody starts out with, and it's a good one to start with because everything is at a lower temperature. PETG, the most popular fiber filament at the moment. I use it almost exclusively. It has most of the properties of ABS, but none of the smell. In fact, you wouldn't know you're printing with it. It's almost odorless. And it is a very, very tough material. It's very good for prototyping. It takes details well, as does PLA. And depending on the size of the nozzle, your step increments, that sort of thing, you can create a model which is something that you can build with. And I have done so, a number of things, including something I put in the rails of my sail to align it. I hoist a laser up the mast and look on the bottom to see where it's pointing. And I built that in Tinkercad and extruded it, and works great. One filament that's quite interesting is thermoplastic polyurethane, or TPU. It's for flexible. And it's a very, very neat filament. You can also, it gives a better grip if you're printing something that you would be holding on to. It's a superior grip. It's a weird thing to print. It takes a few runs at it. And so it's worth a try. I mean, I really do like it for certain things, but it takes a bit of work. So the likelihood is you will start out with PLA and move on to PETG. And when you're using PETG, and the prices are about the same, about $25 for a reel, which is about a kilogram. I get mine are M&G chemicals out of, I get them off Amazon, or I get them from Q-Kits if he has them. And TPU you have to order special. But I used it. I was asked, well, when COVID first started, there was a doctor in Picton wanted someone to model, to print a model for him that he had from an American source of a larynx. And so the purpose of this was to be used as a training aid for nurses up north. And his wife was training basically over Zoom, how to do certain procedures. And of course, with the respiratory ailments that were going on at the time, access to a thyroid, to this is kind of important. So they wanted a model to play with. And I printed it for him out of PLA. And it worked really well, but he came back to me and said, well, I really would like something a little more flexible, a little cartilaginous, a little more like a larynx. And I used TPU, and that was perfect. So the thicker TPU it has some interesting properties. It was well worth looking into. So, busy slide. This is the nuts and bolts of what goes on. Nozzle diameter. You will read lots. Everybody's kind of going with a 0.4 millimeter nozzle diameter right now. That's the size of the hole you're pushing this filament through after it's heated up. I did use 0.1. It works fine. It takes a long time. And some people now have got such sophistication, they're up to 0.8 and 1 millimeter. And so they're printing larger models, but they're doing it very, very quickly. It'd be very good for prototyping if you don't require a high level of resolution. Secondary to resolution is layer height. Every step around where it does an X, Y, this is the Z. I choose a moderate resolution of about 1.5 millimeters, but you can go a lot less. Again, smaller numbers, higher resolution, longer print time. The first thing you do when you get your machine and you're changing filament is you print a calibration piece, which is what that blue thing is behind you in the slide. And the reason that you print these things out, you're looking for problems. So these are standardized, and it changes its temperature as it goes up. So if it cannot print at a certain temperature, it won't go much higher. And what you're looking for here is little strings of plastic in between the towers. You're looking for gaps in the filaments, in the layers, black spots, where especially with PLA, if it stayed too long and it was too hot, you're actually burning the filament, and you will smell. You will see delaminations, you will see warping. Warping is something I was going to talk to Al about. I kept one of the pieces I made for his box here because it warped something horrendous. And that comes down to bed adhesion, which is the last thing. But the next step is, as it's extruding and going through creating its path, when it gets to the end of that path, it'll stop. And what the machine does is it pulls the filament back in a little bit and then zips across to where it's going to start again and waits for a second to push it out a little bit, and then off it goes again. And it knows exactly how to do this based on tests you've run like this. So these are all parameters you can change in Cura or in Pronterface. And these are important parameters for each filament. A lot of them don't change between filaments makers if you stick to the same rough quality of plastic. And that's why I stick with M&G. I'm used to using their materials, so I kind of know what I'm going to get out of it, and I don't have to change any of the parameters. If you make a significant change in your supplier, then you're going to have to recalibrate everything just to make sure it's all working. One of the things that you do is you tell it to print out or to push out, say, 100 millimeters of filament. And you mark it when it starts, you mark it when it ends, and then you measure that and you make sure it's the same. And if it's not, you have to make an adjustment in the system to tell it you're off, your calibration's off, because that's what it's basing the amount of filament that it's putting on your model. Everything's based on that. So most of the time you don't have to worry about it. But when you first start, you have to calibrate a lot of things, because this is a machine that is going to do what the software tells it to do, whether or not the servo motors are doing it. I left the last point because this is a big one, a really big one. Bed adhesion. Bed adhesion is second only to leveling it in terms of a successful model print. The bed has to be 90 degrees to the nozzle, wherever it is. So, in order to flatten it, there's little adjusting screws, 4 corners. And you have to go through a process of leveling it. Now, what I found with my first printer had a glass bed. and it does not change. So I had to flatten it once every dozen or 20 prints. I would go in and just make sure it's okay. And the way I would know it is not okay is I would go to print a model and I would come down an hour and a half later and find this little ball of filament wrapped around the nozzle. It had never stuck to the bed. And that's because it wasn't level. It had not stuck. So with the Ender is not a flat bed. It's not a very expensive printer, and the bed that comes with it is not machined true. So it started out fine, but over a period of usage, using the heater, 70, 80 Celsius all the time, it started to warp, and I couldn't get around it. So what I did was I bought an automatic bed leveler that goes on the printer. And what it does, you saw the G29 code and the G code listing there. It's an automatic leveler. So before it does anything, it goes out and it maps out the bed you're on. And then it develops its own accommodations for any problems with the bed. I haven't had a problem since. The other side of this is bed adhesion. Now, I had a glass bed, and it works great for PLA. And to make it stick, make the filament stick, and it has to do with temperature differences and a few other parameters. What you get into is that you end up printing on blue painter's tape, very common. Or there is a purple brand of glue stick. I'm trying to remember, it's Elmer's. I think it's Elmer's. Anyways, the purple one works very well. And what that does is it gives the filament something to stick onto while you're laying down the first layers. Now, one of the other things you might have noticed in that model I showed you in the blue one was there was a skirt around the bottom of it. That is an additional mechanism for improving bed adhesion. It prints that first, and that's stuck to the bed before you start printing your model. So it gives some substance to where it's printing. Otherwise, as I said, you'll come down to a ball of filament wrapped around your nozzle being dragged around. Not very productive. So, next. What do I suggest? If you don't have a printer, I'm going to plug the Ender 3. Get a heated bed, should come with it, and buy the self-leveling probe with it. If it doesn't come with it, if you're buying it used, if you go to put a self-leveling probe on it, you may have to change the motherboard. I don't see that as being a problem for anybody in this group at all. It's just plug and play. If you're going to use, if you're going to be producing a lot of stuff, you may want to get a more sophisticated bed to start out with what it's got. It's kind of an interesting vinyl material. And what I did, rather than glue it down, they would like you to tear off the two, the double-sided tape underneath this thing and glue it down to the aluminum bed that's on it. I do not do that. I paper clip it on. There's little black spring clips. Because there's going to come a time when you can't get your part off the bed. And this happened to me with PETG and the glass bed. PETG does not do well with glass. I didn't know that. So the first time I printed PETG, I was able to get it off. The second time, I was risking breaking the glass to get it off the bed. So in that case, it was painter's tape, and then I proceeded along with the Ender 3. So things that stick to the bed, painter's tape, purple glue stick, or you can buy a specialized kind of material. But to start with PLA and the stock bed material, Cura Slicer is the easiest, simplest, free one that's out there. And it has all the settings for all the Ender printers already in it. In fact, it has many, many, many printers built right into it. So all you do is select, I have a Pressa 3, i3, and it'll pick your bed volume, it'll pick your build volume, it'll set your X and Y's for you, it'll set up where your zeros are, everything. Now, because SOAREX is a group of people who tend to do things kind of from scratch, if you're building one Then I recommend that you load your Arduino with Marlin software. It's the most common. The first one out there was RepRap. I don't think it's as common anymore. Marlin is the one everybody uses. Get a bed that can be leveled. I literally have little leveling screws at 4 corners on the glass one. PEI Flex is a material, very, very useful kind of material. It's a strange, almost metallized vinyl. It's an odd material. Anyways, one of the members of SOAREX, Asaf, printed commercially and relied on this material heavily. I bought some of it, and yeah, it's really good. Things do not stick to it permanently, but they do stick to it well enough that you don't come down and find the dreaded ball of filament. You want a bed that can be heated. You need a heated bed to make most of this stuff work. Otherwise, it's going to pop off. Direct extrusion versus a Bowden tube. Okay, this is a discussion that takes. There's 2 camps. Obviously, there's always 2 camps. Direct drive, literally, a little wheel grabs the filament and forces it right into the heating area, and then out the nozzle. So it directly grabs onto the filament. It's easy to get at. It's easier to maintain. I actually prefer it. The Ender 3 does not come with that specifically. What it comes with instead is a Bowden tube. And what that is, you have a direct extrusion device, and then it shoots it down through this Teflon pipe and into the heater. And I'm not really sure the benefits of this. I'm not sure where it came from. It seems to work okay. It took a little bit of getting used to. Now, you could not print TPU with this. TPU, you need a direct extrusion, and you need to adjust the inside of your direct extrusion because the TPU will melt and bunch up at the top of the heating chamber. So depending on what you're going to be primarily printing, if you have an Ender 3, you're going to have a Bowden tube. That's fine. I don't think TPU works that well with a Bowden tube. There are upgrades for everything, and I bought most of the upgrades, including a Teflon Bowden tube, which I guess helped things a bit. I'm not really sure. I didn't see much difference. If you're going to do this from stock, I do recommend you use Cura. I do recommend you start with PLA, and you'll have to tell it all the calibration parts: build volume, size of your bed, where you want your X and Y to be. It's very important. Where you set the initial start point, the home point. One of the things that I found was I was printing away very merrily for some length of time with my first printer without realizing that it was actually printing backwards. The X and Y's were reversed. And I didn't find it out until I printed out something with writing on it. And it came out mirror image. So, very, very important last point. Don't ever leave these things alone. The drivers on the H-bridge for the, I think they're MOSFETs, had a habit of catching on fire. This is where 3D printers used to catch on fire. They had these things cut very close in terms of tolerances. And because you're drawing a fair amount of current through these things for the heaters, you could cause a fire. And this is where they were coming from. Not so much a problem now. Most of these machines are far more sophisticated, and most of the companies have learned that it's not wise to burn down your customer's house, so build it so that it has some protection in it. But be very careful of leaving them alone, because strange things happen when you're not there, including when the filaments are supplied in these large reels, even from a decent supplier, there will be a crossover inside sometimes. What that means is the filament can't be released. Well, you've got a very small gear wheel pulling very, very hard, and over a period of time, something's going to give. Usually what happens is it'll break the filament somewhere. But I have had a couple of support arms broken because a filament got trapped and you couldn't get loose. So I actually have a little closed circuit TV watching that I can watch from it. So if I do have to leave it, I can keep an eye on it. Come on. There we go. So setting up the slicer. These are the 5 primary parameters you have to worry about. And they're the biggest things you have to worry about with any of it. Remembering the last point, that has to be calibrated so you and the printer both understand that if it says it's going to print 40 meters of filament, it's actually going to print 40 meters of filament. And this is my friend Boris Karloff, and I couldn't find the ad with the A1 steak sauce where he says experiment with it, but you're only starting, and there is so much to play with. You could easily make this your sole hobby. And it's probably one of the most interesting things I've ever done, because I can make things and more or less robotically create things that I could never manufacture in any other fashion. One aspect that I'm getting involved with one of our other CAREX members, who is a fellow that has a forge, is you can take PLA, make a part, put that part in sand, and pour hot metal into it. It'll dissolve and destroy the PLA, and basically vaporize it. And so it's a lost mold form of casting. So you can do an awful lot of things with this. I have many, many parts that I have made that they've survived the weather. I use them for dipole centers. I use them for all kinds of things. Lots of radio stuff. And I can only urge you to add this to your quiver of tools. Because it's a really big topic. And I sent Peter the PowerPoint. There's a whole bunch of things you can look at and learn about and consult when you run into problems. There's even the Science Direct is an article on PLA versus PETG in terms of mechanical characteristics, if you're actually at that depth. But I would urge you to just go play with it. It's remarkable what you can find, what you can do, and ultimately, even my wife found it useful because she does acrylic pouring, and I had to create some devices for her so she could pour various patterns using these little guides and pouring things. And yeah, they were all in there, and I printed them out, and now my 3D printer has gained new regard in her eyes. And with that, my presentation should be done.
All right. Thank you very much for that, Drew. Yeah, a very good overview. And even though I've been 3D printing for a couple of years now, I guess, I definitely learned a few things there that I didn't know before. A lot of it was the acronyms. I've been saying a lot of those 3-letter, 4-letter words, but not knowing some of the details behind them, which is actually kind of interesting. So yeah, no, I appreciate that. Definitely a few tips and tricks. PETG is something that I haven't tried yet. I'm solely a PLA guy at this point, but PETG I think will be the next stage in my journey. So Ken, I see you've got your hand up. Please go ahead.
Besides any modifications you made, like the bed and all that stuff, what was the time period for the learning curve?
Well, I actually was printing 5 days after I got it.
Oh, really? That's pretty good.
YouTube is your friend.
Sometimes.
And you know, well, I got this from a guy who had already run it. And then he had built part of it so that it could do nylon. Well, I didn't want to do nylon, but it was remarkably fast. I found it's a technology that you can dive into, and then as you make mistakes, you go back and fix it. But I would really recommend just getting in there and printing a few things. They like you to print this hokey little tugboat to begin with. I never ever have printed the hokey little tugboat, but yeah, I was making stuff in 5 days.
Oh, very good, very good. Thanks, Drew.
Yeah, sure.
Yeah, I know. I would agree. When Dave and I put our Ender 3s together a couple of years back, we were up and running within, I would say, well, definitely the same day we started making prints come out. Yeah, we needed to learn a few things, but it was good. So not too bad. The Ender 3 at least is pretty much ready to go if you are careful with your assembly of it, and I think Dave would agree with that. So, yeah. Peter, go ahead.
Drew, you mentioned when you were printing with TPU that you would take a few runs at it. Obviously, something must be going wrong, and you got to make some adjustments. So, what would you be seeing when you make a run, and then what goes wrong with it, and what did you do to correct it?
Okay, well, the first problem was the temperature, and I assumed because it was a very flexible filament that it melted at a lower temperature than even PLA, and this was not true. And so the first thing I had to do was run calibration blocks to get it running, and that's when I discovered calibration blocks. Was I didn't know these things existed, and there's a variety of them. There's also a dimension one that you can buy. Well, you don't buy it; you can just download it. It looks like a dice, but it has letters on it, and you print that out. That's how you find out whether or not it's printing backwards or whether it's printing properly. But the first thing I had to do was get the temperature right and the feed rate. So I set it up the same as PLA to start with, and then I increased the temperature at the nozzle until I was getting something that wasn't giving me stringing. So you overshoot and come back. Ended up the temperature is about 190 Celsius, which is in between PETG and PLA. But it took. I've got some pretty interesting little pieces of modern art sitting around here that I keep as on the wall, saying, "Remember this? Don't do this again."
Thanks, Drew.
Sure.
Okay. I don't see any more hands up. So that is that. Sorry, just quickly scanning the chat here to see if there's anything relevant to our discussion, but I don't see anything there either. So, okay. All right. So, yeah, thanks once again, Drew, for that overview. I think I'll be actually referring back to that presentation a few times. Would you mind possibly posting your slides for that, Drew?
I sent them to Peter.
You did? Okay.
And I have them. I put them on my Google Drive. How would you like to do that?
Yeah, well, a shareable link to your drive would be good if you've got it there. That'd be simple.
Yep.
Maybe just put it in the chat.
I'm gonna have to.
If you can. If not, then
I'll
post to SOAREX. Whatever works.
Just something to think about.
All right. Peter?
Well, going forward, I mean, I have started it, but we haven't gone too far with it. But I guess the idea really is to convert. Hang on a second. Yeah, the idea is to convert the presentations into PDFs, and then we can load it up to our website. And then you can go there and you can check out the links from there.
I can do that.
But like I say, I just started. I've got maybe 2 presentations loaded up there. But going forward, maybe. I mean, I don't think we should go all the way back to day 1, but maybe this year convert a lot of our presentations to PDFs and then load them up. Anyway,
I can do that right now, Peter.
Well, I'm not going to upload it just for a while.
No, but if that's a better format, I mean, I have it as an open office document.
Yeah, so a PDF would be.
Well, see, because we're using the free version on WordPress, the only files it'll accept is PDFs or JPEG.
Sure. Oh, that's fine. That's easy to do.
Okay. All right. Thank you very much, Drew. So on to Peter, if you are ready for LT Spice to illuminate us.
You can all see that?
Not yet.
Oh, you know what? I forgot to do something. Hang on.
Yeah, share it.
I blasted some of you guys for not doing it right after all this time. I made the mistake myself. Who'd we scare off? Nobody. Okay. Okay, there.
There we go.
So LT Spice 101-ish. And I say ish because it's not really a basic tutorial. Not from a start from scratch. And that's why I sent out some links earlier on. You know, some of the guys had expressed, I think about 4 people expressed a basics kind of LT Spice. But YouTube and well, I was about to say LT, but it's actually Analog Devices. They got some really good videos and stuff like that. And it's probably best to take a look at the basics there. They can do a better job than I can do. And plus you can get some of the, the real basics down pat. And then when we do these kinds of presentations, we can kind of, move forward with something a little bit more interesting and whatnot than actually doing the real basic stuff. So that's why I call it 101-ish. Brief overview to get you started. I've got some links at the end. But you know what? Google's your friend with this one. There's, Google LT Spice, and then you'll be lost for days. And like I said, once the basics are understood, then we can really get into some good stuff. And what is it? Well, it's a widely used, free to download electronic circuit simulation software that was originally done by Linear Technology, now taken over by Analog Devices. A GUI schematic capture. Yeah, it's the, I guess LT Spices is their, they use the Spice engine. I think a lot of programs do. Schematics can be probed to produce simulation results viewed through the waveform finder, which is really a good thing. Limitations, the accuracy of the models. There's some good models out there and bad models and in between, of course, like anything, I suppose. But understanding the behavior of your components in the circuit and how they interact with each other also help identify whether the accuracy of the model that you're using. And in some cases, your models don't necessarily have to be totally accurate, especially if you understand that. And to be able to make, in order to make Spice a useful tool. It does not take into account the physical layout of the circuit. So you got to keep that in mind. It may work great on the simulations, but when you put it all on a board, there's something that goes wrong. So that's another good reason for understanding how circuits interact with each other, or components, I should say. Same thing with some of the settings you may put in there. You may put in too much power, too much voltage, or whatever the case may be, and Spice will happily simulate it, and there won't be any little symbols of smoke coming out of the components you have on your simulator, because it just doesn't do it. It just simulates that it's okay. Complexity, more complex circuits, and the resource intensity. That's, I'm just referring to, if you get some circuits, especially the one out of the last ones I've been doing, can really tie up the resources of your computer, which of course would really increase the simulation time. Some convergence issues, which is basically resolving the simulation. I never really ran into any problems there. I'm not even a first-year apprentice on convergence issues, although I started to get into that a little bit with the active probe, but just something to be aware of. Why I think it's worth the time to learn. Well, I think it's a valuable tool in any of our toolboxes when we're homebrewing. It gives you a chance to identify faults, eliminate inefficiencies that can cause problems way before you put it into your breadboard or do anything assembly style or whatever the case may be. Cuts development time in designing circuits for sure. Much easier to go through changes on the screen than it is popping in and out of resistors of breadboarding and soldering or desoldering and all these kinds of things. And then of course you got all the probing and wires all over the place that create other problems. Work out all the details in Spice first and then go to the breadboard, proof of concept boards, whichever way you do it. Assist in troubleshooting challenging circuits. Here, maybe you're having a problem with an existing circuit. You can put it into Spice and that particular part of the circuit and see if you can duplicate it and try to sort out what's going on. This is a good one here. Learn how circuits operate by simulation. It's much easier to say, take an op-amp circuit, put it in LT Spice and play with the feedback resistors and what have you. increase the rail voltages, ground the negative rail, supply negative rail voltage to the, and see what happens. Much easier, much quicker to do that in LT Spice. Same thing with bandpass filters, change some capacitors and see how the effects on the circuit is and whatnot. So you can really get a good handle on how circuits operate by just simulating them instead of taking the extra time. Once you go through that, then put it on a breadboard and see how it goes. And that's always a good exercise as well too, is that real LT Spice in the real world. Run circuit changes through LT Spice first. Maybe you got a circuit that's working and you want to improve on it. Let's see an example, maybe an op amp, change a resistor to change the gain. Did you go the right direction? Or did you go too far? You can do that in LT Spice. That would give you an idea of what value of component that you might need to change in your real circuit. And then you would see how close you come. Rumor has it it's the best simulation program out there. Certainly it does what I need it to do. Huge online support, that's for sure. Like I was mentioning earlier, Google it, and you'll get all kinds of YouTube videos, help support videos, and again, Analog Devices has a ton of videos as well. A lot of these guys who do these online YouTube channels and stuff on electronics and whatnot, they also have LT Spice simulations that they do also. So there's another source to find information. Groups.io, of course, LT Spice group there is a huge resource there. I've used them a few times, and those guys are probably, there's beginners on that forum as well, but they're generally intermediate to experienced, expert guys. So there's probably not much you could throw at them that they haven't heard before or could not help you with. The only thing I suggest is before you post a question there is make sure you read the help files and do a little bit of research yourself, because that'll be one of the first things they might say. Have you looked in the help file to answer your questions? They don't suffer fools. But again, don't let that scare you off from asking for help from those guys. And of course, there's a few here in SOAREX that use it. So there's nothing like having the friendly face or the guy next door kind of thing to help out with whatever you may be doing. And of course, it's free. Okay, I'm not going to do a demo in the scheme of things of a demo per se, but I will do just to show a couple of little things. Let's see here. Okay, we can see that.
Yes, sir.
Okay, so all I really want to kind of point out here is just a couple of things that would help you with laying out your schematics and whatnot. And then when we go forward down the road with some of the simulations that we'll be doing, it'll become important. What I'm referring to here is labeling. Now up here in the top left, you can see VCC input, and then I make reference down to here, input, and then VCC over here in the top center. Two things here. One is it saves congestion on your schematic, drawing extra lines so you can eliminate that part. The other thing that's useful for it, and here I've labeled base, is that when you go to run your program or your simulations, and I'll do that in a second, and you'll see, actually I'll do that now, and then you can see exactly what I'm talking about. So we'll just do a quick there, and I'm going to do an add a plot plane. So you right click in the plot, and then you just go down to add plot pane, and now that one will become active. So when you touch your probe on the next thing here, and I'm going to do it on the output, the waveform will go up on that screen. Now in this case, if I put it on the same plot, it wouldn't be so bad because the voltages are close enough together that it doesn't look, one waveform isn't squashed, shall we say. But I get in the habit of using most of the time separate plot planes. Blue I find is a little bit hard to hear, so just right click on the label, and then you can change the color, and you can make it a little bit more easier to see. So and I think I'll just add another pane here. And I'm just going to click into here on this R4 resistor. I'll change this color. So you can see here at the bottom here in the green, it's labeled V input. So, well, we know what that is. V output for the red. And then we have here for the purple, V node 02. Now, in this case, it's a pretty simple circuit. We know that the node 2 is the emitter. But if you get into a little more, well, actually, you don't even have to get into a complex schematic. You add a couple of components in there, active components and things like that. You start clicking on the wave on different various parts of the circuit, and you will quickly have on your screen node 2, node 4, node 5, and you think, what the heck is all that? So that's why I'm saying it's probably a good idea to, at least the areas that you're really interested in, put a label on it. Start getting into the habit of that, because like I say, going forward, when we start talking about using the air logs and stuff, you'll want to be definitely using labels. Let's see, what else can I do here? Oh, I think most of us know the cursors. Just very quickly, you right click. Sorry, let me do it here. Right click up here where on the name, and then you would just come down to here, and you can either select just one or two. And then in this case, I'm just going to go with 2 cursors. Then when you hover over what, you can see the one, and then you can move it and peak it, or where you think the peak is. Now I'm going down there. So now you can read off what your voltage is of the 2 probes, and then what the differential is between the 2. I'm just quickly showing that. One of the problems with using the cursors is placing it exactly where it should be. It's, you think, oh yeah, you're kind of there, but maybe you're off a little bit. So that's one problem with the cursors. And like I say, going forward in future demos, we'll talk about how we can get around that. I think that's pretty much all I wanted to show for here tonight. Changing components. I think we all know you just right click. In this case here, you can pick a new transistor, so you can select whatever's in the library. And the other components is, you just right click, and then you can change the value of the components. I think most of us know all that anyway. But I think that's all I wanted to show for the demo. Are we back at this, seeing this again?
So you did close your desktop. Is that what you're asking?
Okay, so I got to reshare my screen. Okay.
Beep, beep.
Okay, here we go. I'm assuming we can see that?
Yep.
Okay, so once you get a little bit comfortable with entering schematics and all these kinds of things, and the basics, Spice inside on the chart on the right, they have what they call educational, and then there's a whole slew of sample circuits that you can open up and play around with. Some of them are not too bad, some of them are fairly complex or quite complex, but you can explore through that. The box on the left is showing something they call jigs. Some devices, when you right click some of the devices, now in the case where I right clicked on the transistor, it just says pick a new transistor. Well, some components or devices within LT Spice, when you right click on it, it'll say, do you want to open up the macro model or macro jig, or I can't remember exactly what it's called. And that's what it's referring to over here. And it shows you what's going on inside with that particular component, which is kind of cool. So getting started, my recommendations is, well, develop your own circuit. Nothing like just doing something and putting it in yourself and playing around with it. Another thing to a little bit more on that would be, well, you start a new project that you're interested in doing, and then the first thing you do is put it in LT Spice and then play around with it in Spice before you get around to using KiCad or whatever your next step is going to be in actually building the circuit. Or another good idea, I think, is take a project that you've already built, put it into LT Spice, and then start playing around with the simulations, and then compare it to your project. And that's a good way of seeing what's going on there. And you don't necessarily have to do the entire circuit either. You can just take a portion of a circuit and do that. And of course, doing that, view and analyze, play around with the graphical tools, plot the voltage and current waveforms, all those kinds of things that get you comfortable with the tools that are there, at least the basic ones. Alter the values, observe the effects in the waveform viewer, and then breadboard the circuit and make comparisons. But I think the good one too, I think the best one there might be LT Spice a previous project or a portion of it, and then give it a shot. So going forward, I'd say is once we're comfortable with the basics, then we can start talking about parameter sweeps, varying component values with Spice directives instead of right-clicking a component, making a change, then rerunning the simulation, make some cursor measurements, and then seeing those results. Then go back, change another value, change the value again, at least going back and forth. Doing Spice directives takes a lot of that pain out of the equation and makes it much, much nicer to do. Play with other waveforms like in a pulse wave, or for example, doing a square wave, we can play with that. Importing models, that's always a good one. Explore the FFT function in Spice. And probably my favorite tool in all of LT Spice is using the dot measure directive. Now, you can use it for dot measure. You can either use dot mes as I got here, or lowercase, uppercase. It doesn't matter. Spice will accept it. But this here will help you reduce the need for cursor measurements, as I mentioned earlier. It'll calculate circuit values for you automatically. You can utilize formulas within there to make some of the calculations you want. Whether it be a power example. Or another one formula you can use is a gain of an amplifier circuit. This will be all come into utilizing the Spice error log, which will help you aid in documentation. And this is where you definitely want to use labels in your circuit, because when you get to your Spice error log, you're going to have all this data in here. And when you use the labels in your circuits, then it'll be you'll be able to find the data that you want easily. So what this ends up doing, I call it complicating the simulation in order to simplify. You'll spend more time setting up your simulation at the front end of things, getting it all set to go. But once you get going with it, it'll really simplify things and make your simulation time go even quicker, because to manually input stuff can be a real pain, especially if you're doing a lot of it. Here's the links I have here, but again, like I said, get around to a PDF and then we'll put up on the website, so that makes it a little bit more easier to find. Or I guess when it gets, I'm not sure when I'm going to get it all done, but that's what the plan is anyways. But again, just Google and you find all kinds of information. Yeah.
Can you leave your schematic up for a sec?
Which schematic? This one?
You
mean the one that's in the LT Spice?
Yeah, the one you got there on the screen now.
Okay.
Can I ask a question now, or are you done?
No, yeah, go ahead. Yeah.
Oh, okay. That input view one, those parameters in the sign, the 100M, is that 100 megahertz or 100 milliseconds?
Okay, no, the sine wave, the 0 means 0 offset, 0 DC offset. 100M is 100 millivolts peak.
Oh, okay.
So if you looked at it's a bit hard to tell from this particular screenshot, but if you looked at the green, it would actually be 200 millivolts peak to peak. So you have to be aware that when you're using that statement in there, it's the voltage is in peak. And then the frequency is the next one along at 1 kilohertz.
Oh, okay.
Okay. Anything else?
Oh, just one more question. What's that dot tran at the bottom?
Simulation time.
Oh, okay.
You may find in this case here, that's probably way too large. But when you're messing about things, you kind of lose track of where you're at with some of it. But and that's where I just end up there. Quite often sometimes you'll increase the time a little bit because maybe you need your circuit to settle down, at the front end of the simulation. So you may need a longer time for it to settle down. In this case, it's such a simple circuit, you probably wouldn't need to be that long.
That's
Okay.
in milliseconds?
Well, that in there, that's not in real time.
Okay. Okay, Dave, go ahead, please.
Uh-oh.
No, I didn't. I hit the wrong button. I just wanted to put in what tran is. It's transient analysis that starts at 0 seconds and goes all the way to 150 milliseconds.
Okay.
All right.
So I guess then, I guess I noticed the couple of the guys that were interested in basic stuff and talking about LT space aren't here tonight. But a couple of that are interested are here tonight, so that's good. So I don't know if anybody's had a chance to start messing about a little bit with some of the basic functions of learning the the different icons, what they mean, and doing stuff. But try to get doing something on there, and then, like I say, going forward, we'll get into some more interesting details of space.
Okay, any further questions for Peter from the group? That's it. Okay. All right. Well, thank you for that introduction, Peter. I've played around a little bit with LT Spice, but that was a good little, prod to maybe crack it open again and start working on my own common emitter amplifier, which you give me some, little hints there. Hold your breath now, Peter. Al, go ahead.
Okay, it's probably out in left field. Are there any schematics or devices for vacuum tubes in all these libraries?
I believe so, but I see on the LT Spice IO group that they do every once in a while. Somebody talks about that, but I've not done that myself. Well, I'm sure there's vacuum tube models out there, but I couldn't answer that for sure.
Okay, thanks.
I presume there are custom libraries that can be imported into LT Spice. Is that?
You can do that. Yeah, there's some. There's a wiki that's been set up with and maintained by a Russian guy who's one of the real experts in this stuff, and he's got a wiki up there with all kinds of models. And I think you can actually download his models into your program.
What about components? Have you seen component libraries?
Well, I've gone and like for I went out and reached out and got a model for like an op amp that I needed, and I brought that into LT Spice. So yes. Now there's another thing too. I think you have to be careful. And I'm not sure. I'm going to have to pay attention to this myself because I better start practicing what I'm about to preach. There's a way where you can insert a model into an existing library in LT Spice. The problem with doing that is that when LT Spice goes for an update its models, you will lose anything you've put in there. So it's recommended that when you import any kind of models and stuff, you make a custom library, that kind of thing, so that when LT Spice goes through an update, you don't lose the models that you have imported or built yourself, for that matter. Now, I don't import models hardly at all, so every time I go to do that, I have to go to YouTube and watch somebody else do it, because I tried it, oh, that didn't work, and then okay, so watch your YouTube, and then away you go. Anyway.
Okay. Alrighty. Well, if there are no further questions, thank you very much, Peter, for that. Is there going to be a part 3?
You know what? I've got all kinds of explanations and ideas to show everybody. So there'll probably be more brief demos of things than a full-blown presentation, which I think will be really informative and useful. Basically, it's ideas of how to use the different directives and things like that. In the case, like I was saying, dot measure statements, how do you use that? And from making measurements, say automatically measuring the voltage in, voltage out, using a formula to calculate the gain, calculate frequencies. Um, the list is, it really truly is your imagination, right?
I have an idea. You could give us homework.
I did already. Look at the posting a few weeks ago. Start reviewing the basic YouTube videos. So who's done that?
Well, I'm saying something we have to present, something we have to bring, to show.
Oh, okay.
Yeah. All right. Before I, he who speaks may be the first one to be assigned a task. So got to be careful.
Yeah, I assigned you a task. Common emitter amplifier. Sort it out. Done.
On LT Spice. Okay. All right. 7-3 Charlie. All right. So thank you once again, Peter, for that very illuminating, discussion on LT Spice. So I guess I'm going to just briefly get a straw poll here of who is. Should I actually use the poll function or not? I don't know. I could, I guess, but I could just do a thumbs up in your video when it comes to.
Just raise your hand. Just raise your hand. Raise your hand.
Dude,
and you'll see the count. Right. No, raise your hand and you'll see the count at the top of the screen for hands raised.
Yeah. So who in principle here is planning on, I guess, more than 50% chance that they're going to be attending Hamvention in May of this coming year? So got 2, 1, 2. Anyone going once, going twice? No. Okay. All right.
Bueller?
What about Eric? What about him?
Yeah. Well, I'm running the poll, so I'm number 3. So
Hassan is a one trip wonder.
Who? Hassan?
Yeah.
Didn't
you go last year, Hassan? I can't remember now.
No, I didn't. I was almost able to go.
Oh, that's what you almost.
I think Ken said he's going too. I think Ken said next year he.
Yeah.
Okay. The reason I ask is we're just trying to figure out.
And
Yeah. So there's a few people that aren't here, but I just wanted to get an idea of those still remaining here on the meeting. So unfortunately, the place we stayed at last year is not available. It was actually ideal because it was situated halfway between both the Green County Fairgrounds in Xenia and where FDIM is held in Fairborn, a suburb of Dayton. So it's not available. One place that I looked at a few months back has now jumped from, I think it was around 200 a night to 442 a night or something like that. So that place is out of the running. There's nothing special about it particularly, but there still are a number of places available for what would work out based on 6 people staying. And like I said, there's 4, I think, right here that we know are quite likely coming, but adding another 2 shouldn't be a problem. But looking at about $30 or $40 per person per night, so roughly in line with the cost last year. And so I guess really the question is start pondering, and I'll maybe put this out as a SOAREX poll, is what day we're going to be congregating, getting down there. We went for 6 nights last year. That seemed maybe a touch long, so we're looking at either, I would say, 4 or 5 nights. In the past, we've done the 4 nights, just show up Wednesday night, and then boom, Thursday morning, you're right into FDIM, and you basically don't stop from there. Going an extra night is kind of nice, a little more civilized, because you have that day buffer in between the beginning of FDIM and Hamvention. So anyway, these are things just to think about for those that are pondering or maybe sitting on the fence. There will be room in this house for at least a couple more, and we could probably even squeeze in more than that if you're willing to couch, sleep or bring a cot or whatever. So anyway, so like I said, I will put that out to SOAREX mailing list and get some more numbers, because we really do want to consider reserving our place sooner than later. We're about 7 months away from the event, so things are starting to book up in that area. It's a popular place that weekend in the area there. So any comments from those assembled that are going?
I like going down the Tuesday, the one night before, so that would be 5 nights?
5 nights, yep. Okay. All right. Anyway, that was it. So short and sweet. Like I said, get this ball rolling and get something reserved. Right now, the prices on the ones that remaining are pretty reasonable. Like I said, there are places that will sleep up to 6 people for 151 Canadian a night. So pretty reasonable. And we got the whole place to ourselves, which worked out nicely last year. So, all right. So on to the last portion of the meeting. We're just before 9 o'clock, where we'll just do a little brief round the screen, around the bench. Peter, you said something there? No, we're good. Okay.
I can if you want me to.
Oh yeah, why not? Since you're first thing on my clockwise screen here. So
Okay.
What's happening?
I have not been melting any solder, but I have managed to get a divorce from LT Spice for a while on the active probe. And I've moved on to KeyCAD, and so I'm putting that circuit in there. I've got a board designed, so we'll see what's going on there. See you, Dave. This is the circuit I've got where I've added the op amp into it. Otherwise, if you're interested in building the thing, an active probe as the poor man's is, then Dwayne's got the Gerbers already figured out for that one. But anyway, that's all I've been doing is active probe stuff, but I've moved on to the KeyCAD portion of it now, which is kind of great. So I'm very close to actually moving on to FlatCam, which is going to start generating this G code that we just went through with the 3D printing. Anyway, that's it for me, Eric.
Okay. All right. Thank you, Peter. Frank, how about yourself? What's happening down Windsor Way?
Yes, I've still been working on the Hot Water 9 Heath kit there, and the building of it is completed now. I'm doing the calibration. It's going a lot slower than I thought, but not necessarily because of technical problems, that too, but because of other stuff I've been involved in. So mostly medical, etc. and whatnot. But it's coming along, and I haven't given up on it yet or thrown it against the wall. So I'm hoping to have it running shortly. So that's about all I've done.
All right. Looking forward to a demo of that once up and running, Frank. So.
Right, will do.
Yep. All right. Okay, thank you very much, Frank. Al, how about yourself? What have you been up to there? I know you've got something because you're always tinkering.
Well, yes, always tinkering, but I'm afraid I'm empty-handed today. Still trying to get the house in order for the fall. I think I mentioned a couple of weeks ago I had a major antenna failure, so I'm learning how to mortar bricks on my chimney and put the antenna mast back up. So really no time to do any circuitry, but once this heat wave gets over and we get into the fall weather, I'm sure I'm going to get back into the shack and do a little bit more. It's looking forward to doing a QSO with Frank on the HW9. I might have to work on mine as well. I have an 8 and a Hot Water 9, and I had them out on the patio last weekend, and I was a little disappointed to see a lack of RF gain on the Hot Water 9. whereas the hot water 8 just blows my socks off. So fortunately, I've got all the manuals and the alignment procedures for it. So that may be this fall's project, is to go through the entire calibration and alignment procedure on the hot water 9. So that's basically it for now. Maybe I'll have some more on the next meeting.
All right. Okay, fair enough. Thanks very much, Al, for that. Drew, how about yourself? What's going on
Well,
in 2001 land there?
yeah. Well, some time ago, Phil got me into remembering what I used to know about APRS, and I went to dig up an old tracker that I had, and I found that I can't find it. So I went about building one. And so I got an Arduino, a little GPS chip, and some software. And now I've got myself an SA818 VHF module, which is a 1-watt transmitter. And I'm going to build myself a little tracker. And it's kind of interesting because, of course, you're staring at these things, you have no idea if they're working or not. And, you know, it transmits, it's only going to transmit for half a second every whatever. So now I'm sitting there with an oscilloscope watching it very closely. So it's kind of fun. I've never done anything like this before. I'm just bolting together parts and see how it works. So far, it seems to be working okay. I know at least the Arduino's reading the GPS. And once I took a look at what people are charging to sell these things, I see my time is well spent, because I could waste a lot of time on this and still, you know, not come close to a Bionics tracker for like 150 American. So that's what I'm doing. I'm playing around with it. And the SA818 VHF module is kind of interesting. I didn't realize how common it was, but it's very, very small. And this could be a nice little compact unit. That's my toy. That's what I'm doing. I'm going to end up doing LT Spice, I know, on a couple of things, because I'm trying to get the GPS signal out of out of that chip into various modes, and I wanted to turn it into an NMEA 0183 style, which is a 12 volt, and it only puts out 5. So I'm talking to EAC about converting it and inverting it to a 12 volt invert signal. And that's going to lend itself very nicely to an LT Spice model, I think, Peter, as a way of learning. So that's what I got.
So I'm very curious, Drew, would this circuit that you're making in its entirety, would it fit onto a dog collar?
A big dog.
Big dog, yeah. Okay.
I mean, especially one that doesn't run that fast. Although I think your tripod there will run really fast, because I've seen them run before, and the one leg missing doesn't slow them down at all.
No, not at all. You're right.
No, people think it does, and no, it can actually, I think, run faster.
Yeah, it tries harder, right? So
and the corners are easier.
That's right. Yeah,
So,
no, this
I
guy
think
can go. He just centers his back leg and boom.
I think it would fit. It's not that big. The biggest part of it right now is an Arduino R3, the Uno. And I tried to get it to work with a Nano. Didn't have any luck with it, but that's just programming. It was a software library issue. The Nano wouldn't support the library. Otherwise, it would have worked. So, yeah, I was intending on something, you know, not very big. So I'll let you know if it works.
Yeah, no, I'd be highly interested. I've been examining different options, LoRa and other things. So
this thing came from LoRa.
Okay.
This device is used. There's a couple of them out there that do use LoRa, which are what, 433?
I
433 megahertz, something like that.
Yeah, I believe. Or does it do the double?
Or 900.
I think it might be the higher end. Yeah,
might be 900. Yeah, I've seen those LoRa modules, and I was trying to figure out what they were about. And I guess they're like a Zigbee. They're basically just a little transmitter serial connection sort of thing.
Yeah, but even slower, right? I mean, extremely slow rate, but you know that it's the range, right? Many kilometers, right? So.
Well, 433. Well, even the 2 meters. The 2 meters, you know, if you put it on the APRS signal and just put it on a dog as an icon, you could watch it from space.
Right. Okay. All right. Yeah. Well, I'll be interested to hear your progress there. So, thank you. Okay.
Question for Al.
Sorry?
Question for Al.
Yeah.
Did you ever get that case, Bill?
Which one?
The one I printed for you.
You never printed me a case. Maybe another Al.
For the U-bit? U-bit X?
No.
No.
Hmm.
Never mind.
Sorry.
It was somebody in SOAREX.
Was it somebody that comes to our meetings?
Yeah.
Huh. Okay. I guess you'll have to investigate. I think, Al, you were the only Al that has attended our meeting
Yeah.
online.
I'll have to go look it up.
Yeah.
Yeah, look at the emails. I thought it was
I wonder
Al.
who I built that for.
Yep.
And what's it for?
Yeah, for a U-bit X.
I don't even own a Ubix X.
You don't have a U-bit X. I'll have to take a look. That's a mystery. Isn't that weird? Oh, well, never mind. Carry on.
If I buy one, I know who to ask.
I don't know. Maybe he's let the cat out of the bag. Maybe you're getting a Christmas present, Al. You know, a microbit X with a case.
Isn't that weird?
All right. Al, thanks very much. Sorry, Al, Drew.
Yeah,
so,
sure.
Dwayne, what's happening down in Georgia?
Oh, haven't been doing anything on electronic for a while. All my home brewing lately has been of the liquid kind.
Okay. All right. Well, I just got pinged from my brewing buddy who's asking to brew on the 14th. So I'm triple booked now, camping in Algonquin, brewing beer, and going to Kingston for a ham fest. So I'll have to decide. But anyway, you must be doing well. Lots of experimentation, eh? What have you got in the keg now?
Actually, lately I've been doing a bunch of farm wines and stuff like that.
Oh, okay.
Just little gallon batches and stuff like that. So
Yep.
you can go and play with it and figure out what you want if you want to make more of it. And then there's always the fun of testing, making sure it works out okay.
Right. Yeah. Nice. Now, 'tis the season, I guess. Getting ready for winter.
It is for sure, because I finally got around to clean all my lines, the keg out. It's all done now. It's all ready to make my next batch, but I think I'll do another stem.
All right, Hassan, what have you got to share with us?
All right. So here's what just a sec. How do I switch this camera around? So I've actually been doing the mechanical models. This is a boat along the Grand Bank Story. So I'm building a model boat, just because I needed a break from all things technical. And here's a robot arm I got as a gift from one of the students we had over the summer. Some hydraulic action. So I assembled this thing. Had a lot of fun with that. But yeah, I decided that I can't. I told you guys the problem. My workbenches are too messy, so there's no space to do anything. This is the current one of them. So until I clean up and get some desk space, I can't do anything. So that's my conundrum right now.
Yeah, a common complaint. I'm sure either we're all there or we all have been there. So
We can send Eric down there to clean out your shack for you.
oh, I don't know.
Just
Not too many of my spaces are neat and tidy.
Well, if you guys want to stage an intervention, come on down and help me clean stuff up. Because actually, I got home today and the garage was all cleaned up. So apparently they're redoing the kitchen cabinets, and they decided to use my garage to stage it. So something's clean at least. I'll do the rest later. But just been super busy at work, man. Unbelievably busy. All my spare time. Hopefully it'll be over soon.
All right. Okay, very good. Thanks for the show and tell there, Hassan. So, as far as myself, not a whole lot of solder melting either, or LT spicing, or any of that at this point. Yeah. But look what I have. I have a nice shiny new frequency counter. That was, again, I didn't make it. And you can't see the screen, unfortunately.
You didn't make it, it doesn't count.
Angle I hold it at, but the contrast doesn't vary. But anyway, it goes from, I don't know, I'm told a couple hertz up to the, whatever, 200-300 megahertz, something like that. So tested it. It kind of works. Haven't tested the full range, but that was sitting on one of the flea market tables at the Ancaster Hamilton Hamfest this past weekend that I went to. So got that along with the little gimbal thing. But the major actually thing that I picked up there was something I've been looking at, which was a portable antenna. So something I can take with me when I travel. So it's a buddy pole. Guy had one that was in basically new condition. So looking forward to putting that through its paces. And like I said, one of my few working antennas at the moment. So there you go. Drew.
Something you might want to try. There's been a thing recently where they've been putting a screen down on the ground instead of radials.
Okay.
As a counterpoise. It's been very well regarded. So they take like chicken screen.
Yeah, Dave did that.
Yeah, it's apparently really effective.
Okay.
Take a 10-foot roll of 4 foot wide and put it underneath the tripod and try that with the buddy pole. They say it really makes a big difference.
Or even like aluminum screening for a screen window or screen door, right? Would do the same kind of thing, right? So, okay, all right, yeah, thank you. I'll put that on the list. So, other than that, not a whole lot. Like I said, I've been pulling my hair out with computer issues at work over the last couple of weeks. So, no, none of that. None of that happening. So on the benches need to be cleaned up. So I'm in Hassan's situation too before I really get going on anything. Clear some stuff off, make some room, and go from there. So
there's always a bigger bench, Eric.
Yeah, I could. Well, the problem is my family is starting to count the number of work tables I have, and it is getting embarrassingly high. So like 3 in the furnace room, 2 in the music studio, at least 2 in the tool room, so, 1 in the office, got them all over the place. And only the office one is clean. Yeah.
Yes, I know exactly what you're talking about. But if I had a barn like you did, I don't know, could you ever run out of space like that?
Oh, it's like a gas in a container. It expands to fill the volume. So yeah, it's bad. But I did manage to do an oil change in like under 60 minutes today. I found all the tools, even though they were buried under things. So.
Hey, oil changes. This is the wrong forum to talk about oil changes.
It was father-daughter bonding time. She said, "Dad, can you help me change my oil in the car?" We talked about common emitter amplifier circuits while we were changing the oil too. So you'll be pleased about that, Peter.
No. We could use the old oil for an oil-filled capacitor or something.
That's true, or a dummy load, right? An oil.
That's right.
Just hope it doesn't explode. So. All right. Okay, gentlemen, 9:15. So I think that's a wrap. Thank you very much for your attendance. And our next meeting is a regular one on Wednesday, the 18th, I believe, 14 days from today, the 4th. So looking forward to seeing you and all of you and everybody else. Hopefully we have a few more faces on our regular meeting. And other than that, 7-3 to you all.
Cheers.
7-3.
Cheers.
All right. See you in a couple weeks.
Yep. See you in a couple weeks, guys. Eric?
Yep.
The 7th. No.